All right, 2.6, we're going to look at rational functions. We're going to look at finding the domain, vertical, horizontal asymptotes. We're also going to look at slant asymptotes. And holes in graphs. A rational function. What is a rational function? Who could say that in terms that we all understand? What's it look like? A what? What's a rational number?
A number that can be shown as a fraction.
A fraction. So a rational function is going to be something that looks like a fraction. Nx over dx. The domain is all reals except those values that make the denominator 0. Because why? Because we can't divide by 0. So for example 1, over x, what's its domain?
Over 0? No. It's greater than 0.
Well, we know that x, the denominator, cannot equal 0. So can I put any other number in there? Can I put 5? Can I put a fraction and a half? Negative 5? Yeah, any number can be x except for 0. So it's all real except x cannot be 0. If we want to write that in interval notation, we can write it like that. Now let's plug in these numbers and see what we get. So what's 1 over negative 1? Negative 1. What's 1 over negative a half? What's that? No. 1 divided by 1 half. Negative 2. What's a negative 1 over 0.1? I'm sorry, it's a positive 1 over negative 0.1. So that's 1 divided by 1/10, negative 10. This is 1 divided by negative 0.01, which is 1 divided by 1/100th. So that's a negative 100. And what's 1 divided by 0.0001? Instead of a negative 1,000. So what happens as x approaches 0 from the left? What does this mean? Here's 0. What's happening? And if this is negative 1, where is negative 1,000th located on this number line? It's really close to 0. Okay? So what's happening to all these numbers as I approach 0 from this side? We're getting closer and closer to what? So, okay, these numbers here, so okay, let me back, I'm not saying this right. As x approaches 0 from the negative, so as I get closer and closer to 0, what's happening to my y values here? They're getting smaller and smaller and smaller, so they're approaching negative infinity. So now what happens when I plug in the positive forms of these? We get 1, 2, 10, 100, 1,000. So now what's happening as I approach 0 from this side, what's happening, the smaller and smaller and smaller my x value gets, what's happening to my y value? They're going to infinity. And you guys know what the 1 over x graph looks like because that's one of those from the parent graph from our quiz. So what's happening here is we have two asymptotes. First of all, we have a vertical asymptote at x equals 0. That's because of this denominator. Because this is from the denominator. Y equals 0, we also have a horizontal because if I take 1 and I divide it by anything, will it ever be 0? It's never going to be 0. It's going to get really, really close to it because the bigger I make x, if I make x 1 million, what's y going to be? It's going to be 1 over 1 million, which is going to be really super, super small, but it's still not quite 0. And if I make it 1 trillion, 1 over 1 trillion is even going to be even smaller, but it's still not yet 0. Okay, so we have on 1 over x, we have a vertical and a horizontal asymptote. And we're going to look at the rules for those. And this is kind of where it comes from. So a vertical asymptote. The line x equals a is a vertical asymptote of the graph f if x approaches positive infinity as x approaches a, either from the left or the right. The graph of this rational function, n of x and d of x, where n of x and d of x have no common factors, that's important, no common factors, it will have a vertical asymptote when d of x equals 0. When your denominator is 0, we're going to have vertical asymptotes. This shows up in calculus. Horizontal asymptotes will show up in calculus. A horizontal asymptote is found, and there's 3 different ways, The first one, a horizontal asymptote at y equals 0. So we have a horizontal asymptote at y equals 0 if n is less than m. N is the degree of your numerator. M is the degree of your denominator. So, for example, if we had x squared on top and x cubed minus 9 on bottom. What's the degree of the numerator? 2. What's the degree of your denominator? Is the degree of the numerator less than the degree of the denominator? So we are guaranteed a horizontal asymptote at y equals 0. Okay? You need to know these rules. A horizontal asymptote at y equals the ratio of your leading coefficients if the degrees are equal. So for example, if I had f of x equals 2x squared minus 3 over 5x squared. Oh, let's go plus 2. Let's go 2x. There we What's the degree of your numerator? What's the degree of your denominator? So the degrees are equivalent, so it's got a horizontal asymptote at the ratio of your leading coefficients. So what are your leading coefficients? 2 and 5. So this one has at y equals 2/5. And then there's no horizontal asymptote if the degree in the numerator the degree of the numerator is bigger. There's none. We're going to talk about what type of asymptote is here in just a minute. So example 2, we want to find all horizontal and vertical asymptotes. So where do I find vertical asymptotes at? It's where the denominator is 0. So where does x squared minus 1 equal 0? Add 1 to both sides. Whoops. So vertical asymptote at x equals 1 and x equals negative 1. Horizontal asymptote. Which rule applies? 1, 2, or 3 here? 2. Rule 2. Because n equals m. So it's going to be at y equals, what's your leading coefficients? 5 and 1. So at y equals 5. Questions there? All right, first thing you should do, and I should have talked about that over here at A, I didn't, is do some factoring first. So like in example B, x squared minus 4, what does it factor to? It's the difference of perfect squares. The denominator has a GCF of x, right? So that's x squared minus x minus 6. And x squared minus x minus 6 factors to what? x minus 3, x plus 2. Now notice up here that the vertical asymptote, the graph of the rational functions, has no common factors. We'll have that has no common factors. We'll have vertical asymptotes where the denominator equals 0. Okay? When we factored this, what common factors do they have? They have the x plus 2's, right? And let's add this. A hole in the graph will occur when a common factor cancels. It occurs when the common factor equals 0. Because in the original function, x minus 2 is still undefined. It's still not defined, right? So this graph has a hole at x equals negative 2. The factor cancels out. We're going to have a hole where that factor equals 0. Because it's still not part of the original domain. Then our vertical asymptote is found where the remaining denominator equals 0. So this is found at x equals 0 and x equals 3. Questions there? Horizontal asymptote. Which rule applies here? 1, 2, or 3? 1. Because the degree in the numerator, so n, little n, is what? What's the degree in your numerator? 2. What's the degree in your denominator? 3. So it's rule 1. Because n is less than m, so y equals 0 is a horizontal asymptote. Everyone know how to find degrees? I guess I'm assuming you know what the degree is. It's just the highest exponent. Questions there? Anyone not done? Guidelines for sketching a graph. Simplify it. Find and plot the y-intercepts. That's where you evaluate 0. Find and plot the x-intercepts. It's where your numerator is 0. That's the only time that fraction will be 0. Find and sketch your vertical asymptotes, your horizontal asymptotes. Plot at least one point between and one point beyond each x-intercept and vertical asymptote, and use smooth graphs then to connect, where you will be approaching your vertical asymptotes. Now, a graph can cross a horizontal asymptote. Okay? Let's just make that note. A horizontal asymptote is simply a point or an asymptote where the graph approaches it. It might cross it and then come back down and approach it. Okay? There are graphs where it will cross. And then what I've done in the notes is I've set this stuff up. I've set these steps up for you. So for the first one, y-intercept. How do I find the y-intercept? Find f of 0. So that's going to be 1 over x plus, or 0 plus 3, which is 1/3. As I find it, plot those points. 1/3. It's about right here. X-intercept is when 0, you just set your numerator equal to 0. Will 0 ever equal 1? No, there's no x-intercept here. So that means that graph is not going to cross that x-axis. Vertical asymptotes are found where? Well, this one can't be simplified anymore. So a vertical asymptote is where your denominator equals 0. So at x equals -3, asymptotes are graphed with dotted lines. Horizontal asymptote. Rule 1, 2, or 3. What's the degree of your numerator? 0. What's your degree of your denominator? 1. So n is little n is less than m. So y equals 0 is our horizontal asymptote. Find some additional points. Well, we know that on this side, this graph is not going to cross here. Let's see if how my graph is going to go. Let's pick a negative 2 for x. That's 1 over 1, which is what? So negative 2, 1. So now I've got a smooth graph. It's approaching asymptotes. We don't know what's going to happen over here. We don't know if we're going to be graphed down here or we're going to be up here. So plug in a point over here. Let's do negative 4. So what do I get when I plug in negative 4 for x? 1 over negative 1, which is negative 1. So now I know this part of the graph is going to be here. And then your domain is all x except for x can't be negative 3. Questions there? Anyone not done? Let's go to example 5. First of all, can I simplify 3x over x squared plus x minus 2? Can I do any factoring?
Factor on the bottom.
We can factor the bottom. So f of x is going to be 3x on top. It's going to be on bottom. X plus 2 and x minus 1. When you go to find your y-intercept, I always plug it into my original because that means all these x's go to 0. So I get 0 over negative 2, which equals what? 0. Where do I find my x-intercepts?
They're just the zeros.
It's where the numerator equals 0, which is also 0. Where do I find vertical asymptotes? Where the denominator equals 0. So that's at negative 2 and 1. My grandson got A pluses on everything in his homework yesterday. He's only in second grade, but still. All right. Horizontal asymptotes. Where are those found? Which rule? Rule 1, because the degree in the numerator is 1, the degree in the denominator is 2, so n is less than m, so that's rule number 1, so it's at y equals 0, which you sure can. So here is a case where we have an asymptote on the x-axis, but our graph is going to cross it. We're going to have to do several additional points here. Let's start over here. Let's do 2. What happens when I plug in 2? Get 6 in the numerator and 4 in the denominator. So 3 halves. So that's 1 1/2. Let's get another point on that side. Let's do 3. And I'm using this one here. So when I plug in 3, what's 3 times 3? 9. So I get 5 and 2. Question? And then 3 9/10. So over 3 9/10 is right here. So I can see my graph is going to go like this. Will it ever be negative? Because remember, we can cross this. Well, anything bigger than 5, it's going to be positive up here. It's going to be positive down here. So it's always going to be positive. So we're never going to cross that horizontal asymptote. Now what happens in here? Let's put in a negative 1. Well, we get a negative 3 on top. What do we get? 1 times negative 2. So we get 1 1/2 again. Okay, so this one's going to go like this. So we know we're not going to come back down because it only crosses that one time. What happens at a half? This could go up this way. So when I plug in a half, we get 3 halves at the top, and we get 2 1/2, which is what? 5 halves times a negative. So between all of this, we know our answer is going to be what? Positive divided by negative? Negative. So I don't care what it is. I know that I'm going to go down here. Okay? I don't care what the value is. I just care that I'm which side of that x-axis I'm on. And then over on this side of the question, this says 3 halves on top, and I'm dividing it by 5 halves times negative 1/2. So I have a positive divided by negative which means I'm negative, which means I'm below that. That's all I care about. We're sketching. We're not making exact. And then on this side, let's plug in -3. So when I plug in -3, what do I get at the top? -9. On the bottom, -1 times -4. So we get -9/4. So -3, -9/4, that's 2 1/4. Remember, I cannot cross this horizontal asymptote again. I know that this graph is going to be below that horizontal asymptote. I know I'm never going to cross it again. I can only cross it at the x-intercepts. Since this is down here, everything else has to be, and we always approach asymptotes. So our domain is all real, except x cannot be what? -2, and x cannot be 1. We're finding asymptotes, we're finding intercepts, and then we're figuring out what's happening to that curve in between those asymptotes. Not doing exact values, we're doing guesstimates. We're sketching. If I wanted an exact, I'd tell you to pick up this graphing calculator. I would tell you to plug it in here, and I would say now plot those points. And if we wanted to check our work, notice here, I'll know if you used a graphing calculator because what's missing? The asymptotes. They're missing. And when I ask you to do this stuff, I'm going to give you something just like this. I'm going to ask you to fill in everything. This might help you to see if you've got it graphed right, but it's not going to help you fill out all this. Okay? A great tool to check your work. Great tool to check your work. All right. Example 6. Oh, what's the first thing I ask you to do here? Simplify. So x squared minus 4 factors 2. X squared plus 5x plus 6. So this cancels out. And so it simplifies to x minus 2 and x plus 3. And let's just go over here. And we have a hole at x equals what? How do I find that point? Find f of negative 2 of the simplified function. Plug in negative 2 to that simplified function.
Did you move it?
Oh, sorry. I thought it was up there. Didn't leave a space for the hole. Let's get it right over here. So when I plug in negative 2 minus 2 is negative 4. Negative 2 plus 3 is 1. So at negative 2, negative 4, we have a hole. Okay, y-intercept is where? Plug in 0 here, what do you get?
Get 2 over 3.
Negative 2/3. So down here somewhere.
You plotted positive 2, negative positive.
Yes, I did.
Good job, Bobby.
Thank you. I'd eventually figured it out. Things were going. I go, what did I do wrong? X-intercepts are what? Where the numerator equals 0.
Why is that a circle before?
Because it was negative 2, negative 4. Negative 2, negative 4. I plotted 2, negative 4. This is a 1. Yeah. Negative 2 plus 3 is 1. Vertical asymptotes are where? Where the denominator equals 0. Horizontal asymptote. Its rule, let's see, what's the degree in the numerator? 1. 1. Go to our simplified one. N is 1, M is 1. So it's rule number 2, which is the ratio of your leading coefficients, which is 1. We have enough points on this side. Let's get a point over here. Negative 4. So that's a negative 4 minus 2 over negative 4 plus 3. Maybe 6, so it's 6. So negative 4, 6. Like that. questions here? All right, one more example. The cost, C, in millions of dollars for removing P% of the industrial and municipal pollutants discharged into a river is given by the cost equals 255P over 100 minus P. 0 is less than, so P is between 0 and 100. A proposed new law requires companies to remove 80% of their pollutants discharged into the river. The current law requires 45% removal. How much additional cost would the companies incur as a result of this law? So what do you have to do here? What do I have to do? You need to find the cost to remove 80%, the cost to remove 45%. We're going to plug it into this formula. What is P for this one? It's 80. You are so used to, when you're dealing with percentages, to make it a decimal. In this case, the formula took that into account, and they told you that P is between 0 and 100. So they're telling you don't make it a decimal. So C equals 255 times 80 all over 100 minus 80. And guys, I'm going to truly believe you know how to use your calculator. Okay? But I noticed, I'm looking at this going, 255 times 80 divided by 20 is definitely not going to give me this big a number. It only gives me 1,020. What happened? It says that it's in millions of dollars. So when you do your calculator, you got 1,020, but it's in $1 million. So that's $1,020 million. That's where the extra 6 zeros came from. And then for this one, 255 times 45 over 100 minus 45 gives you 2008, 636, 000. And what's the additional cost going to be? What do I do to find that? Do I add them? You subtract. It's going to cost them $811,364,000 to remove. So whatever this company is making, what's going to happen to the cost of its product? It's going to go up. It's going to go up.